Hello, my dear students. Our lesson for today, Chapter 5, Gases. Lesson 1, Properties of Gases and Boyle's Law. Properties of Gases. Brownian motion, intermolecular spaces, compressibility of gases. First, we start with Brownian motion. Gases moves with random motion. That is motion called Brownian motion. To explain that, we make this experiment. If we examine the smoke of a candle using a microscope, we notice that the minute carbon particles of the smoke are moving random in all directions. This random motion, but not by this way. But this motion of this particle by this way, it collide with wall of containers and collide with gases particles. The carbon particle move in certain direction through short distance due to the resultant force on a carbon by air molecules. Gases molecules move in random motion. They collide with each other and with the wall of container. This collisions produces pressure, so the pressure of container of gases become higher. Intermolecular spaces. The intermolecular spaces, there is an experiment to prove that. We have two cylinders. One of them contains gases with low density, NH3, ammonia gases, and other gases with high density, HCl, hydrochloric gases, separated by paper. When we remove this paper, there is a white cloud forming NH4Cl, ammonium chloride. That is white cloud diffuses until it occupies all the spaces within the two cylinders. There are large intermolecular distances separating gases molecules, which are called intermolecular spaces. When we have amount of gases in container with piston, when we press this amount of gases, but we doesn't increase that temperature, we are found the volume of these gases decreases when pressure increases. What about when we increase temperature? When we increase temperature, the collision between gases particles increases, so pressure increases. So we have relation between pressure, temperature, and volume of gases. Gases laws, relation between pressure, volume, and temperature. Relation between pressure and volume, that is called Boyle's law. Relation between volume and temperature at constant pressure, called Charles' law. Relation between temperature and pressure at constant volume, that is pressure law or Joule. Relation between pressure and volume and temperature, that is universe law. So we have rule for that relation: B volume equal nRT, where B pressure, volume, N number of moles, R universe constant, T temperature. When we talk about that is temperature unit Kelvin and Celsius. The relation between Kelvin and Celsius scale as we are. So 0 Kelvin equivalent to negative 273. 273 at Kelvin scale equivalent to 0 Celsius. 4 Celsius equivalent to 277. So the relation between temperature in Kelvin equal temperature in Celsius plus 273. Boyle's law. Boyle's law, relation between volume and pressure at constant temperature. Boyle's law. In Boyle's law, we use thin tube, enclosed gases. We heat these gases and near and close it to mercury and let it or left it to become cool. These gases contract and the drop of mercury enters this tube. In this case, pressure of the enclosed gas equal air pressure, and the volume we can calculate and determine it by using ruler. To increase pressure, as we saw in this figure, we invert this thin tube. The pressure become equal air pressure plus pressure of mercury drop, and volume decreases. To decrease pressure, as we show in figure 2, pressure become air pressure minus pressure of droplets of mercury, and volume become increases. We have a relation between volume and pressure by that is experiment. We have reading for volume and for pressure. The relation between pressure and volume, that is inverse relation. Boyle's law experiment. As we show in this figure, Boyle's apparatus, there is 2 tubes, one of them enclosed with tape and contains enclosed gas. The 2 tubes connected by rubber pipe containing mercury liquid. The pressure in this case at point A and B equal pressure of gases equal air pressure. This experiment at constant temperature. When we need to increase pressure or to increase pressure, we left the right tube upside. So pressure increase, pressure equal air pressure and pressure of this liquid, because the pressure at 2 points A and B equivalent. So the volume of enclosed gas increase, comparable with the first case. In third case, we need to decrease pressure, so we move the right tube downwards. In this case, pressure decrease, pressure equal air pressure minus pressure of this liquid. So the volume increases of the enclosed gases. So the relation between pressure and volume inversely proportional, and the relation between pressure and reciprocal of volume directly proportional. The extension intersect with origin 0 point, and relation between volume and reciprocal of pressure direct relation. The extension of this line intersect with 0 origin. So the relation between volume directly proportional with reciprocal of pressure. So the P times volume equal constant at constant temperature. Boyle's law applied on gases. When we increase pressure, then certain limit, gases become liquid. So Boyle's law not applied, which we can illustrates that in this figure with color red. In this area, by increasing pressure, volume doesn't change. In this graph, by increasing pressure, volume doesn't change. And by increasing volume, pressure doesn't change. And in this color red, in this graph also. Problems. There is two notes for problems. In this graph, relation between volume and pressure. There is two triangle ABC and EDC. We need to prove that the two areas for two triangles are equivalent. According to Boyle's law, the pressure times volume at point E and at point E equal. So BC times AB equal DC times ED. By multiplying two sides by half, so the triangle areas are equivalent. Problem 2. We have an bubble inside liquid. When this bubble moves to surface of this liquid, its radius increase to double. R increase to 2R. We can't call that volume increase to double because volume calculated by this relation 4/3 by cubic R. So volume increases 8 times. 2 power 3 equal 8. When we have value for pressure in this case equal air pressure plus rho GH, and volume as we have in our problem B dash BA only times new volume 8 volume. So we can calculate air pressure and volume as we have in our problem.